shows how the temperature changes as the substance is heated up. Okay?
Yes.
And this we will draw on heating curve over here, the way he's drawing. Okay?
Yes.
While the x, yes, this is the heating curve of water. Do you agree, all of you?
Yes.
Yes, all of you know. Fahad, thumbs up?
Yes.
Yes.
Okay, excellent. This is the heating curve, okay? Now see here. Here, we can see that the temperature of water increases as heat is added, okay? We know that. Let's suppose here we can see that the temperature of water increases as the heated, but suddenly we can see that we reached a point where the temperature remains constant, correct? While heat is being absorbed. Okay, what happens? At this point is when a substance changes its phase. This point, this area, this area, this area. And this region of the heating curve is called as plateau. You don't have to remember this. So now all the heat that is being absorbed by the substance, okay, remember this line is important. All the heat which is being absorbed by the substance, that heat is being used for what reason? Let's see. To convert the substance from solid phase to liquid phase. Is the statement clear?
Yes.
Yes.
Fahad, Amir?
Yes.
Okay, just show me thumbs up if you don't want to speak, okay? Now, so let's see what happened next. Now, once that heat is used, what will happen? After all the solid substances have been melted, yes, into liquid, the temperature of liquid begins to increase, okay? Again, as the heat is absorbed. Then the liquid will then begin to boil when enough heat has been absorbed. Remember, again, the liquid is absorbing all the heat. For what?
To turn to a gas.
Exactly.
Gas, right?
Now that heat will be used to convert that liquid to gas, and that's why the temperature is constant here. Okay?
Yes.
Again, apply it, we will see, and then it will use that heat to convert that thing to gas. Now, if you will continue to increase the heat, the same things will happen. Okay? Okay, now let's see if you can answer these questions. Number one, so what does the y and x-axis represent on the heating curve?
The temperature.
Okay,
the y-axis tells the temperature.
Y-axis tells the temperature. Do you all agree?
No. The x-axis tells the temperature, and the y-axis tells us what happens to the thing.
Okay, let's see. Over here, Aman. Y-axis is telling the temperature. Okay? Y-axis always tells the temperature. Okay, everyone, Fatima? What are the three phases of matter? All of you know. Solid, liquid, gas. Easy. Third, what is the name of the region where the temperature remains constant? Yes, it is called plateau. You don't have to remember. Okay,
I was
now
gonna
here.
say that. Come on.
You want to see one more time?
No. I said I was gonna say that.
Okay,
Even
that's
though
great.
I don't remember, I remembered, you know.
Oh, okay, awesome. So here, the reason is, remember in the quiz, I asked you a question, guys, what is the state? What is the compound X, the state of compound X on this area? So now tell me, what is that state?
Liquid.
Liquid, always liquid. Yes, because first we used all the energy to convert from solid to liquid. Now from here to here, the things are liquid because the liquid is absorbing energy to convert to gas at this phase. So if something is over here on this line, it will be liquid, okay? Is it more clear now?
Yes.
Because Fahad's answer was wrong. This one, Amir, you were not sure on sublimation. Done. Okay, what next? Here, can you see? I have drawn two curves here, heating and cooling. What's the difference?
Cooling, the temperature always go down, right?
Exactly. Now, if you see here, this is a regular heating curve, correct? We increase the temperature, the things are increasing and the phases are changing. But over here, what happened if something is in gaseous form and I decrease the temperature, I decrease the temperature, what will happen? The gas will release.
Liquid.
Okay, listen here. Yes, the gas will first of all release all the energy. release energy. Over here, they are absorbing energy. Here, they absorb.
Yeah.
Over here, they will release out the energy, and then once they release out all the energy from the gas will change to liquid. The process is called condensing. Okay.
Yes.
Then this liquid will also release out. I'm decreasing the temperature, the energy will be released out, and it will change to solid form or freezing. These two graphs, are they clear?
Yes.
Yes. Yes.
Okay, because I have seen some IGCSE question, instead of giving you heating curves, they will give you cooling curves, and that's torturous, isn't it? So I thought to explain both of them. Any questions here?
No.
No? Things are clear? Sure?
Yep.
Okay, well, this one. Exactly, all gases exert pressure. All the gases in the world, whether it is oxygen, carbon dioxide, nitrogen, they exert pressure. Okay? And that pressure depends on how many things?
Temperature and volume.
Excellent, two things, temperature and volume. What does it mean, temperature here? When we have a cold gas, the molecules of the gas move like this, a small arrow, small vibrations, okay? Some small collisions. But when you heat a gas, the molecules move quickly. The temperature is increased, they get more heat, they get more energy. Now they can collide more with greater force, so their collisions will increase. Do you think that once the collision will increase, they will exert more pressure on the walls of the container or a balloon or anything?
Yeah.
Does it make sense, Fahad? I'm just explaining this topic for Fahad, Amir, and Lamin, okay? Because I saw a lot of confusions there in the group, in the quiz.
Thank you, ma'am.
Yes. Now, this is the first reason why gases exert pressure. The first, depend on temperature. Secondly, they depend on volume. Over here, the gases, the volume, the amount of space they are taking, it's big, correct? So the pressure is less on the wall. Do you agree that if I push this wall down through a piston, I'm applying a pressure, the gas will squeeze and it will exert more pressure on the walls. Do you agree?
Yes.
Yes.
Exactly.
Yeah.
So is it clear that if volume is decreased over here, let me write in a short form. If volume is decreased, the pressure will increase.
Increase, yes.
Excellent. If volume is increased, pressure will decrease.
Yes,
Any
teacher.
confusions now?
Yes.
No.
Excellent. Now for temperature, if temperature is increased, the pressure will
Increase.
if temperature is decreased, the pressure will
Decrease.
Excellent job. Now, the next question, diffusion. What is diffusion? Amir, you can
Teacher,
increase.
how many times?
How many times exactly? I was waiting for that. Teacher, how many times you have to listen diffusion? Yes, diffusion, movement from higher concentration to
Lower
Lower
concentration.
concentration.
remember
Lower
how
concentration.
fast the molecules will move. The rate depends on two things again. This was gases stuff. This is totally different. Diffusion rate, how fast things will go from higher concentration to lower, that depends on two things. First of all, mass of particles. What does mass
And
of particle
temperature.
means? How heavy or light particles are. Is it clear?
Yes.
Yes.
Are you all sure? Fahad,
Yep.
Amir. Okay, that's great. Over here, there was a question in the quiz named as helium gas balloon. Remember?
Yep.
And all of you,
Yeah.
all of you were not able to answer first time. The reason is over here now. Let's suppose on one side of the container here, this part, I have two gases. Okay? One is of purple color and the other one is of green color. Okay? And I separated that gas, okay, through a barrier, and it have a hole inside it. If you have a barrier and things can pass through it, it is called a porous. It's a porous barrier. Remember, porous means that it have holes inside it. Okay. Now, if it have holes, and now the other part after the porous barrier, what things could be observed is this: that the green gas was more on the other side, while on this side the purple gas was more. What could be the reason that green gas moved there?
Because it's lighter.
Exactly. The only reason could be that maybe the green gas is lighter. That's why it moved faster from higher concentration to lower. Okay, then purple one. The temperature you already know. If I increase the temperature, molecules will move faster, they will get more energy, they will collide. Higher to lower concentration, movement will be more. Is it clear?
Yes.
Is 100% sure these two topics, these three things,
Yep.
actually. Heating curves, that's okay, excellent. Awesome, awesome. Now I will never come back to diffusion. It was a
Surely you will one day.
Add diffusion noises.
It's hard, I know, but diffusion is an important topic. You still, you have a whole chapter on diffusion in biology. Whole chapter, yes. I think it's
Okay.
unit number 3 or yes, 3. Okay, the good part that you didn't join early was this, that now I will not teach you more. It will be a short class. And are you happy on that?
No.
Come on, Fatima, these boys will kill you for saying this. No, they're really happy.
No,
Okay.
if I wasn't enjoying her classes, I wouldn't have woken up like
Okay,
for
that's
this
great. I
class.
will take
I would
as a
have
compliment.
continued to sleep.
Okay, the unit 2, the chapter which we're gonna start, it is about separating the mixtures, okay? Again, one of the important topic, but more related to laboratories, okay? You need this topic to when you are working in labs, okay? So that's why it's important.
Yep.
Okay, remember, from here the unit starts. Changes in the world are of 2 types. How many types?
2 types.
2 types.
Physical and chemical.
Exactly, a physical change or a chemical change. What
Chemical
is
change.
physical change and what is chemical change? Let's watch the video and we are done with today's topic. Okay? Everyone is clear? Should I start? Over here. Physical and chemical changes. What is a physical change? A change in the size, shape, or state of matter of substance. Okay? Any change which will change the size of something, shape of something, or a state of something, that change is called as physical change. Thumbs up for that? From everyone? Okay, excellent. Let's start. Yes, we know that. Come on. Okay. Physical change? No new substance is created. Remember, in a physical change, nothing new is created. The things are same. The only thing that will change is
State.
what? State of matter.
The state of the.
State of something. Okay, can you see this paper in my hand? No.
No, teacher.
No, thank you. Thank you for
I
telling me.
can see it.
Oh, come on. Okay, can you see it now? It's a full A4 paper.
Yeah.
It's a full A4 paper. Okay.
Teacher.
If I torn this paper into 2 pieces, like that. Now I have 2 pieces in my hand, correct?
Yes.
Oh,
Yeah.
I learned
You have to
this,
do
I
chemical
failed in
change to
science
make it
because
back
of this.
now.
Okay, excellent. You got it. And the same example he is giving you now. See here. So new substance, no new substances. Over here, he took a paper. He's cutting that paper into 2 pieces. Okay. Is this part still called a paper?
Big edit.
Yep.
Exactly. Do you think a new thing is created?
No.
But the size of the
No.
paper changed?
Yes.
Yes.
This type of changes where nothing new is
Physical
created, the
change.
things remain same. This is called a physical change. Okay? Thumbs up?
Yeah.
Excellent. Okay, yes. Okay, let's move on. Physical change? No. So slime is another example. Have you seen students now, not students, like kids, they play with slime, they will mold the slime, they will make it into different shape, but still it's a slime.
I still
I
play.
never played with slime.
Teacher, I
Okay.
still play with slime now.
Come on, Fatima, the boy is gonna kill you. Don't say
It's
this.
like
Okay,
the smell only kills me.
okay. Now see here, one of the best examples. Over here, he took an ice cube. Ice cube is what? Water, H2O, correct?
Yep.
Water.
He put on a pan, he turned on the heat, and that ice is now turning into liquid. This liquid is still H2O, correct?
Yep.
Do you think a new thing is
Yes.
created?
No.
No,
No.
the only thing happened was that it changed from solid to
The shape and volume.
Liquid.
Exactly, the shape, volume, and the size things changed. Okay, excellent. Best examples. Okay. Okay, what's next? Please move
Diffusion.
on. No. So a physical change again. Now, what is a chemical change? Okay, here. A change in which one kind of matter changes to a different kind of matter. Over here, a new thing will be created. Okay? We will see how the things will react with each other. Okay? Is it clear? So in physical change,
Yep.
nothing new was created here. A new things will be one matter will change to another one. Okay, let's see. Over here, again, a piece of paper, and now I say you to burn that piece of paper. Do you think still it will remain a paper?
No.
No.
Will turn
It will
into
change.
ashes.
Exactly, and that paper is converted to ashes and gas. Okay, is it clear?
Yep.
So this paper
Yes.
completely changed its form. Now it is something else. So this type of change is a chemical change. Okay,
Chemical change.
perfect, you got it. Fireworks, another example. Fireworks, the reality of fireworks, they take this powder and what do? They put on fire and they change to these colors, different colors, okay? It's a chemical change. Yes,
Really, teacher?
exactly, yes. Okay, now the other example, you can perform this in your home when you wake up properly, okay? If your mom have a vinegar at your home, okay, and a baking
Ma'am,
soda.
no one's gonna do
Yeah.
this. You can just skip. No one's
Oh,
gonna do
come
this.
on, it's so fun to see it. So what you can do, you can just take a tablespoon of baking soda and put inside the vinegar and see what will happen. Completely new form gonna produce. Here, this is
It became
called
soda.
exact drinks. It's a chemical change, okay? But the thing is, you will ask, Miss Binthe, we don't know like how to recognize a chemical change. So I'm telling you some techniques, okay? There are some signs to recognize a chemical change. Here they are. If in an experiment you see that there is a change in color, this means there is a chemical change there, okay?
Yes.
Secondly, if you see that there is a change in, okay, it produces a smell, okay? You smell something new, okay? This means there was a chemical change. If you see that there's a releases of gases, it's a chemical change,
Chemical change.
okay? Is there anything? Yes. Change in temperature, there will be a chemical change, okay? In laboratories, you will see many times. Let's suppose in a glass, I'm just saying glass to simplify it, okay? In a glass, you put two liquids together, okay? You put, let's suppose, water and hydrogen chloride maybe. Before putting them, the water was at normal temperature. After mixing both of them, you will see that the temperature of that glass will rise. So this means there was a chemical change happening there. Is it clear?
Oh, yes, teacher.
Okay, so if you see these four signs, there are more signs too, but these four are important. If you see these four changes, this means a chemical change have occurred there. Okay, clear? Thumbs up from everyone? Okay, over here, now tell me, if he is cracking the egg, is this a chemical change or a physical change?
Physical.
Physical, excellent. Why you say so?
Because
There's
like
nothing
changed.
like, yeah.
Nothing have changed. Does the color change? No. Does the
No.
identity change? No. Smell changes? Nothing.
No.
But if
It's a simple egg.
simple egg and it's still there. But what if I put this egg and fry it?
Chemical.
Then it's a chemical change.
Chemical change. Why? Because can you see the color is changing, the texture is changing, the smell will change, isn't it?
Yes, yes.
So this is a chemical change. Thumbs up from everyone? Okay. Now here, cutting a piece of wood, is it a chemical change or a physical change?
Physical change.
Physical change. But over here,
Physical.
he had shown you rusting, okay? Do you know what is rusting?
Yes.
Yes. That
Exactly,
happened to my brother
when a piece of metal or iron turns to that brownish color, correct? So
Yes.
there, is it a chemical change or physical change?
Chemical.
Chemical.
Yes. Can you see in 20 days the color is changed, correct? The texture
Yep.
is changed completely, so it's a chemical change, okay? Now, over here. So here are some signs of chemical changes: change in color, production of smell, formation of gas, formation of precipitate. It's a very fancy term used in biology. Precipitate means a solid powder will form. If you see a precipitation in an experiment, this means a chemical change have occurred, okay? Change
This
in
word
light.
came in our test also.
Yes, exactly. Change in light or heat or temperature. Things clear? Okay, here is
Yes.
a small thing for you to try. Please tell me, dissolving salt into water, physical or chemical?
Go.
Chemical.
Why do you say chemical? Dissolving salt into water, when you dissolve, okay, before dissolving, salt is salty, correct? Water is liquidy.
Yes.
After, when you dissolve it, do you think that salt will turn into sweeter thing? The taste
Oh,
is
no.
changed. Salt in water,
Physical.
water is still
Physical.
liquid. Physical, excellent. Color didn't change, smell didn't happen, texture didn't change. Why are you saying it's a chemical? Okay, burning a matchstick.
This is a chemical change.
It's a chemical change. Why? Because color is changed. You can see fire, correct? Texture is
Yes.
changed. Melting ice. Lamin.
Physical change.
Oh, okay.
Physical.
Okay, this one Lamin will answer. Grinding spices.
Physical.
It's a physical change. Why? Because we just grind it. Nothing changed. All the spices
Yes.
are still. But if we cook them, for sure it will. Okay,
Yeah.
so the things are clear to you. Any questions?
No.
The way I
Yes,
divided
teacher.
it. Yes, please ask.
Are we doing quiz today?
Yes, we will have a quiz. Okay, now here, last thing, and then we will go to quiz. The way I told you that the changes are of two types, remember the properties are of also two types, physical and chemical properties, okay? Now in chemical change, we have noticed that we don't care, we just care that the new thing is not created, correct? Now physical properties that describe the physical characteristics of a substance. Easy? And not how the substance behaves chemically. How they will behave chemically, we don't discuss this in physical properties, okay? Only the physical characteristic. How does a thing look? What is its texture? If I beat it, what will happen? If I boil it, what will happen? If I change, if I put water, what will happen? This all, okay?
Yes.
But what happened in chemical properties? Properties of substance that describe how that substance's chemical composition will change if I put that substance into a specific condition. Okay, so here are some physical properties. Physical properties mean melting and boiling points. If you are discussing about melting and boiling point, you are discussing about physical property. If you are discussing about phases of matter, physical property. But if you discuss about toxicity, pH, flammability, okay, then this means they are chemical properties. What are these terms? We will discuss in the next class, okay?
Yes.
Okay, let's start a quiz and then you are good to go.